Hi, everybody. Welcome to the October version of the Kubernetes Monitoring Helm Chart office hours. I'm Pete Wall, the primary engineer for the Kubernetes Monitoring Helm Chart. I'm excited to see y'all today, and we've got some fun stuff to talk about. So last month, if you caught last month's edition, you'll notice that we released two feature releases in a row, 3.5 and 3.4 and 3.5. I couldn't keep that pace up. We don't have two new feature releases. We are close to releasing 3.6. And so on the agenda, I'm going to talk about what's going to be coming in the 3.6 feature release, and then the next major upcoming features that we have planned. And then as always, we will leave time for questions and answers. So what's coming in 3.6? So 3.6, I'm hoping to release this next week. And there are four major changes that I'd like to bring into this release. The first is to make database observability a full feature. And there's two reasons why I want to do this. It should, first off, for the people who are using this in the open source community, or they're using this with your own deployments of Grafana or whatever, it should bring a more richer experience for monitoring your databases than the existing MySQL integration. But it also will bring in other databases like Postgres. But if you happen to catch the announcements at ObsCon, at our conference, the Grafana Labs conference, ObsCon, a few weeks back, you'll know that we announced that we're releasing our own database observability feature within Grafana Cloud. And what we're trying to do is we're trying to aim that the release of the 3.6 matches up with the public preview for this Grafana Cloud feature. If you haven't found the release notes or seen some of the videos, I highly encourage you to go check those out. There's some really interesting and exciting features there. If you are running databases, MySQL or Postgres are the first two that they're supporting. This will give you really interesting insight into how those databases are performing, even at the query and schema level. So check those out. But for 3.6, we are aiming to make it simple to configure Alloy to get the information out of those databases to enable that to work within Grafana Cloud. Also coming in 3.6, a new service integration, the Istio integration. We've had some stuff in the Helm chart that handles Istio, but it's more handling it in the form of how do we continue to make sure that Alloy works the way we expect it to, given that we're working within an Alloy or a Istio service mesh. This time around, we would like to add the ability to easily scrape the metrics from those Istio sidecars. We've heard a number of requests for people who want to get that sort of stuff, so we want to make sure that we can make it easy to get the Istio sidecar metrics. So that's going to be coming in 3.6 as well. Scrape config. Scrape config is a new Prometheus, or a newish Prometheus custom resource. And so within the Kubernetes Monitoring Helm chart, we have a feature called Prometheus Operator Objects. Right now, you can use that to find and utilize service monitors, pod monitors, and probes to add to some of the functionality of Alloy and use those to scrape your metrics or probe data. Scrape config is kind of more of a general purpose one. The thing that I found that is really interesting about scrape config is that you can use it to target external resources. So service monitors, obviously, for your services within the Kubernetes cluster, pod monitors for pods. Scrape config, you can have it target like a completely external resource from your Kubernetes cluster. So it's highly powerful, and we want to add the functionality for scrape configs into the Kubernetes Monitoring Helm chart. And then finally, a little tweak to one of the default allow lists. We're going to start scraping the init container metrics. This will also go along with a Grafana Cloud feature. The Kubernetes monitoring feature within Grafana Cloud is going to be adding the init container observability. And because there's more and more uses of init containers, even with Istio, we talked about Istio just a few seconds ago, that this should hopefully give some insight into how init containers are behaving onto your Kubernetes cluster. So we want to get ahead of that, start gathering those metrics so that when that feature is available, you'll have the metrics to go behind that. So that's what we have planned for 3.6. Again, I'm aiming for hopefully next week. By the end of next week, we'll be ready to release this. I'm actively working on the database observability stuff right now. Schedules may slip. We'll see how it goes. That was an extra slide. Okay, upcoming features, the things that we're going to be talking about post 3.6. Some of these you'll have seen on previous office hour slides. Some of these are going to be slightly adjusted. So the front end observability feature is still top of mind for us. So how can we make it simple if you are running front end code and you want to connect that into front end observability, but you want to route that through Alloy? This will make that simpler to do. We're running into a few, not issues, but a few things that we need to solve at the technical level as far as how do we make sure that it's an easily understood experience, but also gives the flexibility and power if you have tons of front-end apps that you want to route through this. The ability to deploy without cluster roles. So this one's moved a little bit since the last time. The Alloy project themselves, we've got a change through from the Alloy Helm chart, which kind of backs a lot of the Alloy deployments that we use in the Kubernetes Monitoring Helm chart. The Alloy Helm chart now has the ability to really highly customize the roles and role bindings and cluster roles that it uses. And so that was one of the major things that we were waiting for in order to have the Kubernetes Monitoring Helm chart itself deploy without cluster roles. Now, it's worth mentioning that some functionality is going to require some cluster roles, and I'm thinking about ways that we can use validations within the Helm chart to check for that. For example, anything where you're doing a discovery at the node level. And so things like the cluster metrics feature, as I said here, so more specifically the kubelet or the cAdvisor metrics that come out of cluster metrics, the way that we find those services is to say, first, give me the list of nodes, because there's a kubelet on every single node. So first, find the list of nodes. Well, nodes aren't namespaced. And so to allow Alloy to get the list of nodes, you need to have a cluster role to be able to do that. So we're going to have some caveats around that, and some workarounds for people who want to still deploy without cluster roles. We'll explore those options, but I think this is going to provide a much neater tightening of the security footprint that some people have been asking for. Cloud provider label enrichment, another one that I talked about last month. But again, what we're thinking about doing here is adding the ability to detect if you're on certain cloud providers, AWS or Google or Azure, or things like that, and be able to pull labels from the EC2 instances that you're running in, or the region or something like that, and be able to add those as labels onto your telemetry data. I want to make that a simple process to do. And then agents.md. So I've been very careful, but I also have been looking into a lot of different AI assistant or AI tooling to see if there's ways to build in the artifacts that we need so that you all can use AI tools to easily get answers about how to run and configure the Kubernetes Monitoring Helm chart. Or if you want to join in as a contributor to say, I've got a great new feature idea, or I've got a bug that I want to fix, help me target not only where to make that change, but also how do I run all of the tools to regenerate things to get ready for a PR. So I've been thinking about doing that. The only reason why I haven't just run whatever in it and then commit the file is I want to actually make sure that it's truly useful and actually can help people with their workflows. So these are some of the things that I've got in mind as far as the upcoming features. Maybe it's a 3.7, maybe it's something after that. But that's kind of top of mind for me on the future of the Kubernetes Monitoring Helm chart. All right, that's enough of me talking. Now it's time for questions and answers. So please, if you have any questions about running the Kubernetes Monitoring Helm chart, about any of the features that we talked about, please let me know. Now is the time.
Could you actually jump back to that 3.6 slide?
There you go.
So, okay, database observability. Is this for MySQL Postgres that's running in the cluster alongside Alloy, or could this be utilized with like AWS's remote database services?
That's a great question. So from my understanding, I'll speak from the Helm chart perspective, which is about discoverability of this data. I don't know if I necessarily have an answer for you as far as what the Grafana cloud feature is, but I think as long as you can make the connection, it probably will get some insight into it. From the Helm chart perspective, the way that we connect to these databases, it's the same if you're using the MySQL integration. You build out a data connection string. And so if you can build in the right host port, username, and password to be able to connect and authenticate with that database, I don't see why it wouldn't work.
Okay. Do you know when InfluxDB would be on the roadmap?
Ooh, that's a good question. I don't know.
The reason I'm asking, I'm right in the middle of doing an InfluxDB integration using the private data source connect feature with a
Oh, yeah,
PDC
sure.
agent. And I'm looking at this going, boy, this would be a lot simpler
Yeah,
than
right.
doing. Okay.
Sure.
Istio native metrics.
Yeah.
I'm hoping that would be an opt-in thing because I do a lot of Istio. That generates a lot of metrics, a lot of cardinality.
Sure can. Yeah.
So I definitely make sure that's an opt-in thing.
Yeah.
Um,
The
just
way
for
that
people's, yeah.
yeah. No, thank you for highlighting that. The way that I would target that is it would behave a lot like the other integrations within the Helm chart. So you would
Have to
intentionally
enable it.
go in, tell it, I want to add the Istio integration, and then you would be giving it label matchers to say, scrape the metrics, but only scrape metrics from these pods or from these, areas or something like that. And then probably come in pretty heavily with with an allow list that would filter it down to just like maybe just a certain subset of Istio metrics to start with.
Okay. And then, yeah, that kind of leads into the init containers because you must have seen that Istio has native sidecars on by default. So now the Istio proxy is now an init container. And I think I put a feature request in because I noticed that Kubernetes monitoring app ignored init containers, which we've been running native containers for a while. As a corollary to the Istio integration, are you also working with ambient data plane?
I don't believe so.
Okay, ping me because
Okay.
there's no more sidecars in ambient.
Okay. Yeah. I'll reach out.
Okay, sounds good. That's it. Thank you.
That's great. No, thank you. Thank you for the questions. That's good.
Hey, Pete. I had a question as well. That's all right.
Yeah, of course.
And yeah, again, firstly, thanks so much for running these. These are great. Um, I was wondering about the pod logs feature.
Yeah.
So jumping to something completely different.
Yeah.
And it has the option to exclude namespaces.
Yes.
I was wondering if you've thought about expanding that for other common exclusion types that won't require us to drop down into like the alloy config language embedded into the values file. So like, exclude by pod labels or annotations or just like I don't know if it's like but the common stuff that people might want to exclude from
Right.
log collection.
That's a great question. Here, what I will do. Let me I'm going to stop share and reshare so I can get the whole window. Because what I'd like to do is pull in oh dear, where did they go? There we go. Okay, here. Desktop one. Okay, so what I'm going to do, I'm going to close up some of the things and I'm going to bring in what I'd like to do, if it's going to let me. I'm trying to bring in my IDE here. There we go. Hopefully you can see the IDE.
Yeah.
I'm going to clean up the sidebar here. And what we're going to do is I definitely agree. Like I want to try to make it as easy as possible to like filter down to the pods that you care about. And so you mentioned the exclude namespaces thing there. What I want to make sure is to see like what do we have here already. And I think there is no default or no other exclude things, but we do have, like the label selectors and I think there might have been a field selectors at some point. But while I'm looking at this, are there examples of things that you were, so you're saying like exclude by label, or what other things would you like to see?
Yeah, I think the three that immediately come to mind are by pod label, pod annotation, and the pod image or container.
Oh, I see. Okay.
So like when we migrated out of Datadog to Grafana, the Datadog agent had some of these options as part of its standard config to exclude by.
Sure.
And things like annoying sidecars, which spew out a lot of logs that you don't care about. It's nice to be able to filter out by just that container image rather than finding a way to, pick that out from somewhere else.
So,
But yeah, I guess maybe on a kind of slightly broader point there, it's like anywhere where a person might have to drop down into the Alloy config language within these values files, unless it's something super exotic, it would be really nice if the features evolve to be able to find like a safe way of providing those kind of configuration items.
Sure. Yeah, I could see that. One of the goals has never been one of the goals of the Kubernetes Monitoring Helm chart has been to offer a really full, rich experience and full featured without making you, without requiring you to become Alloy experts, right? But at the same time, I wanted to offer as many hooks into the Alloy config as possible so that when you do need to make, special changes or special rules or things like that, that it's available where it makes sense. But this, I feel like, totally makes sense as far as, an addition. And it should be a fairly simple change. So no, thank you for bringing it up. I think we definitely can bring that in.
Amazing. Thank you very much. Appreciate
this
it.
is why you join the office hours.
yeah. It's top of the list for future
requests. No, I love it. All right, great. Any other questions?
Does Grafana Cloud's adaptive traces, it seems to replace the tail sampling that's in the Helm chart?
That's a really great question. So we've talked a lot with the adaptive telemetry teams about like where does it make sense? Where does it fit to have one place here and one place here and things like that? The biggest advantage and the reason why we still keep the tail sampling in the Helm chart as well as invest time into it, the biggest advantage there is the more sampling that you can do at the cluster level, you save a lot of network transmission costs. And so if part of your bill, a part of, the growing part of the bill is, network egress costs, then doing in-cluster tail sampling is a way to do that.
I wonder if there's a way to have it so that I can add the tail sampling in the Helm chart to, reduce the network bill and everything, but then have the adaptive traces ignore those samples that are coming in. Because I'm looking at it like, geez, if I do a 1%, then I already have 1% tail sampling coming out of the cluster.
Right.
Now I'm going to be doing, and one thing I noticed too is the, I think it's a synthetic checks that we have traces in them, which seem to be, those would be affected by the adaptive tracing, I'm hoping. So that'd be, I think that's a feature request I'm going to put in where the adaptive traces would ignore the things coming out of the Kubernetes cluster because those have already been sampled.
Right. Some sort of flag or some sort of thing that says,
yeah,
hey,
so
don't do
so I'm not doing like 1% of 1%.
Yeah, right.
Yeah. Which would be a very small amount of successful traces coming out of the cluster. But when I saw that, I'm like, oh, I can reduce our tracing coming out of the synthetic. I think it's coming out of the synthetic. I haven't traced it down, but I think that's where it's coming from, or maybe the front end observability. So I don't know. I just noticed that I'm like, oh, okay, the traces are coming in this way, and maybe the adaptive tracing would take care of that, but then that would really clobber, anything coming out of the cluster.
Yeah. Good question. I'll do some asking internally too. But yeah, definitely raise the feature request, and then we can see, if there's a way to make sure that works the way you expect it to.
Yeah, because that would be kind of cool. We could do it both ways.
Yeah.
Hi, Pete. I have a quick question.
Hey, good. Yeah, go for it.
Sorry, maybe you mentioned it, but I just joined. I missed the first part, the big part, actually.
No worries.
And I would like to ask, because I know many people are struggling from this issue based on extracting namespace or pod labels or annotation, dynamically adding the metrics or C-advisor metrics or pod metrics and so on. And the challenge was Prometheus wasn't supporting this initially, as far as I remember.
Yeah.
And last day I saw this was a work on this and pull request, and it's got merged actually.
Okay. Great.
And just want to know if anything upcoming regarding this.
Yeah, no, that's a great question. So to add some context around that for people who are watching the video or for other people on the call, a common ask that we've gotten is, hey, we get all this metrics about my pods or about the containers or something like that. I want to add a label to them that comes from the namespace where they live in. And most frequently that's because you're working in an organization where you'll have a namespace that's dedicated per team, and then you want to attribute these metrics are related to stuff for this team, or these metrics are related to this other stuff for this team. So I totally understand. Interestingly, the OpenTelemetry pipelines offer an easy way to do this, because they have the OpenTelemetry side of things has a component in the chain called the k8s attributes receiver, or the k8s attributes processor. And what it does is it sees data coming in from a pod, and it actually does kind of like an internal, I don't know, kubectl get info about the pod or something like that. It talks to the API server, and they can use that to pull interesting information like namespace labels and annotations, or interesting stuff about the pod, the deployment name that created the pod, that sort of thing. And you can add those as attributes to that OpenTelemetry data. Now, on the Prometheus side, for the metrics that come out of things like cAdvisor or kubestate metrics or node exporter or stuff like that, we haven't been able to do that. And there are two limitations to that. What you just mentioned is that Prometheus didn't have the functionality to do that sort of thing. Partly that was one of the changes I know that I've been waiting for them to merge is at the discovery level. If you can do, you discover all of the pods, which is how we do things like the pod logs feature, or a number of different other features. We discovered pods. Can we also add label information, annotation information from the namespace where they live in? There was a PR that was open for a long time, and then it kind of got a lot of dust on it. And I've been pushing, some folks internally, hey, can we get this moving again? We're getting requests on that. And so I'm glad to hear that there has been, work done to kind of push some of these feature requests forward. When we do get those we should automatically be able to pull that information into the Kubernetes Monitoring Helm chart. One of the other things that's important to keep in mind, and for things like cAdvisor, I think this might still be at play, is that the discovery rules. So if you dove into the Alloy configs at all, and you've looked at the way that Alloy does pod discovery, service discovery, and you've seen like the list of meta labels, show, don't tell. Why don't I pull that up? I can grab this, I'll slide this over here. So here's the Alloy documentation. There we go. And so we go into discovery.kubernetes. So this is the component, the Alloy config component that looks up the Kubernetes objects, the pods or services and something like that. And so if you look at pods, these are all the labels that automatically get filled out for us. So the container name, the container, pod name, all of these sorts of things. You can add all of the node information, so you can get information about the node labels and node annotations given that pod. But namespaces is missing from this. Now, but this works when we are discovering the individual pods. So this would work great for things like the annotation auto discovery feature, where we are looking to scrape metrics directly from whatever pod that we discovered. And the reason why I call out cAdvisor and why cAdvisor becomes a little bit special is that we're not scraping the pod that cAdvisor is giving us metrics about. We're scraping cAdvisor. And so we're not actually discovering the pod that it's talking about. We're discovering the one cAdvisor service that lives on each cluster. And same thing with kubestate metrics. Kubestate metrics gives us a ton of metrics about all of the pods, but we're not scraping the metric from that pod. We're scraping it from the kubestate metrics deployment. And so all of these discovery level meta labels that we get are for kubestate metrics and not for the pods where they're reporting the metrics on. So there are other tools that are in the work for trying to solve that. Interestingly, the Loki side of the components has a solution for this. It's called Loki.enrich. And this is it's an experimental component, but it's something that I've been exploring and seeing if we could do. And what Loki.enrich does is you can match it with a different discovery and then use it to add log labels onto your Loki logs based on matching things. And so like an example that they have down here is, you know, they're actually matching against like an HTTP target, but you're using that to add metadata about the log, the source of the log. You can match it against anything. So, you know, they're just matching on IP address. So something like this could be used. We discover namespaces, and then the log data comes in, and we can use this to associate the pod from that log, or the logs that come from a certain pod, with the namespaces where that pod lives, and then we can, you know, add that sort of thing. So all this to say is it's a complicated thing. I'm glad to see that the Prometheus project is working through some of the backlogs that's making it a challenge. And as soon as the functionality is there, I definitely am going to try to bring that into the Helm chart. So sorry, long answer for a complicated
No,
question.
that's great. Thank you very much. Yeah, because it's a little bit complicated topic.
Oh yeah, well, and thank you. I know you're a frequent contributor into the Helm chart, and you know I appreciate all of the stuff that you brought into the PRs and issue reporting, some of that too. So, all right. So I do want to make one last announcement. Actually, two things, two fun things. I noticed when I was creating these slides, hang on, the first Kubernetes monitoring office hours I did was October last year. So this is the 1-year anniversary of the Kubernetes Monitoring Helm chart office hours. So celebration to all of us. But I'm also going to be at KubeCon next month in a few weeks coming now. So if any of you are going to be there, if you have colleagues that are going to be there, tell them to come by the Grafana booth. I'll be working the booth a good amount of the time. So tell them to stop by and say hi. And we can talk about Kubernetes stuff. And as always, thank you so much. I really appreciate all of the questions. Like I say every single time, we build this project based on community feedback. Some of it live. I mean, goodness gracious, the pod logs exclusion features, like we'll bring that in. Because what's really important to me is that this is a useful project. It helps you save time to get your telemetry and observability stack up and running. So please reach out to us on the Kubernetes Slack or the Kubernetes Slack channel on the Grafana public Slack, grafana.slack.com. Create issues, create PRs at our GitHub on Grafana/k8s-monitoring-helm. And yeah, thank you so much again for joining, and we'll see you next month. All right, take care, everybody.